All right, we are going to go over the question or questions we skipped in this morning's test review. So remember, we're doing set number 3 from USA Test Prep, and the first one we skipped was number 3. So let's take a look at that one. Okay, so we've got a diagram, we've got a bunch of words, it looks like we have some variables going on. Let's take a look at this. So a contractor is building a house with a large hexagonal palladium. Wow, that's some $5 words right there. Hexagonal? Okay, hexagonal we know is 6-sided. Palladium, that must just mean some material they're using for the window. And the contractor is building a large hexagonal palladium window above the front door. He needs to calculate the area of the window. Okay, so we know that's what we're looking for. Area of the window. Cool. The area of the rectangular portion of the window can be represented by the function blah, blah, blah. Okay, so the rectangular portion, that looks like this bit up here. And that's represented by a of x, the area of the rectangular portion, a of x. And that's a function. We'll maybe figure out what that means in a minute. The area of the trapezoidal portion, that must be what's left up here, right? That makes sense. That is a trapezoid. These two are parallel. The area of the trapezoidal portion can be represented by the function blah, a big bunch of stuff. And also, this is not a of t, I don't think. We're using the variable x, so this is definitely in terms of x. I think they actually meant to do t of x. They just got a little bit confused here. So t of x equals this big massive thing. And we want to formulate a function a of w. Actually, nope, they got confused there again. We want this to be in terms of x. Window, like the area of the window in terms of x, that can be used to represent the area of the entire window. All right, so let me actually label this up here. The trapezoid was t of x. And we want to know the area of the whole window. Well, if I just look at this diagram here, I can see the area of the whole window is going to be these two added together. So I'm just going to write that down. W of x equals a of x plus t of x. And so I'm going to add these two together. And this one looks pretty straightforward. 2x squared plus 10x. If I'm looking for combining like terms, that should be pretty easy to handle. But this bit, this is nonsense. I'm going to have to simplify this in order to combine like terms. So that's going to be my first step. That's what I think I'm going to do first. I'm going to simplify t of x before I try to combine these. So I'm just going to write this over here. T of x equals 6 times x plus 15 plus 2x plus 10, all of that over 2. And let's simplify that. Okay, if we look first at just this numerator, we can simplify that first. This is going to be, I'm going to leave the 6 out front, I'm going to leave the 2 on the bottom, and plus x plus 15 plus 2x plus 10. We don't actually need these parentheses because you can switch around plus and they all end up the same. So x plus 2x will combine those like terms to 3x. And 15 plus 10 will combine those like terms to 25. Now we can actually also perform this division as well. 6 divided by 2. So this is 6 times all of this stuff. And then divided by 2. 6 divided by 2 is 3. So we can simplify that as well. So we get 3 times 3x plus 25. Once again, what we did there was that 2 went away and that 6 went to a 3. 6 divided by 2 is 3. And now it's starting to look manageable. 3 times 3x, if we just do distributive property here, 3 times 3x is 9x, 3 times 25 is 75. So that is our simplified value of t of x. And we should be able to take this now and add them together and we will get our answer. So w of x equals a of x is 2x squared plus 10x. 2x squared plus 10x. We're going to add that to t of x. Add 9x plus 75. Let's see, x squared doesn't have any other terms. Digits don't have any other terms. We do have two x's though, so we'll combine those like terms. W of x equals 2x squared plus 10 plus 9 is 19. 19x plus 75. So once again, they just wrote this wrong everywhere. What they actually meant was w of x, but we understand that. And we're looking for the one that's 2x squared plus 19x plus 75, which is right there. That is our answer on this one. D. All right, our next one we skipped was number 6. Okay, this one says, the table shows the blood pressure of 16 clinic patients. What is the interquartile range of the data? So we've been talking in class about interquartile range. We know these refer to box plots, and quartiles divide the data into 4 even groups. The groups all have the same number of members. So if we know there are 16 clinic patients, which is way easier than counting all of these numbers over here, there are 16 total, they just told us that. We know that We know that 16 divided by 4 is 4. So each of these groups is going to have 4 data points in it. 4, 4, 4, and 4. We know that Q1 falls right here, Q3 falls right here, and our median is right in the middle. Notice that these fall in between numbers. Q1 falls in between those two, Q3 falls in between those two, and median falls in. So if we were to calculate any of these values, we're going to have to do that average thing. We have to find the number right in the middle of those two. So we want to find the interquartile range. We know that the IQR, the interquartile range, is the length, the distance in between the quartiles. We look at that word, inter, between quartiles, in between the quartiles. So we think of that as the length of this box. And we define it as the difference between Q3 and Q1. Which tells us actually we don't need to calculate all of these statistics to find the IQR. All we need to know is the Q1 and the Q3. Well, to know the Q1 and the Q3, what do we need to know? Q1 is right between these two numbers. So actually, maybe we only need those two for Q1 and these two for Q3. And then we can calculate the IQR. We actually don't need all of the values. We could just limit it to, let's see, this is 1, 2, 3, data point number 4, data point number 5, and then this is 16, 15, 14, 13, and 12. So those are the only data points we're interested, 4 and 5, and 12 and 13. So that may help us, it may not, but it might mean we don't have to sort all this stuff in between. So let's try listing these in order now. So I'm going to look at my data set. It looks like I have stuff in the tens, 60s, 70s, 80s, 90s, hundreds. So I'm going to divide these up. That's what makes sense to my brain. I have 60s, 70s, 80s, 90s, and hundreds. And I'm going to go through my data and look for my 60s first. 8, 8, 8, 9, 9, 6. Oh, there's one, 6. And that's actually the only one, 69.4. Maybe we can cross that off as we use it. Okay, so let's look for our 70s. 8, 8, 8, 8, 8, 8, 8, 9, 8, 10, 9, 9, 7, 7, 9. Okay, so I have two 70s, and those are pretty easy to put in order. This one goes first, then that one, so 75.2. And then 78.9 goes next. And notice already we've found data point 1, data point 2, data point 3. We're interested in 4 and 5, so we actually only need to find the next two. We need to find the lowest 80 and the second lowest 80. So let's go through this list and look for 80s, and I'm going to mark the low ones. So 81 is pretty low. I'm going to mark that as possible. 84 is kind of in the middle. 87, 82 looks pretty low. 82.0 is pretty low. 88, 86, no, those are higher. And that's all the 80s. So I'm down to these three. I need to find the two lowest of these three. Looks like 81.6 is the lowest. So that'll be next, 81.6. And then 82.0 is the lowest of those two. So that'll be my fifth value, 4 and 5. Okay, so we've got 4 and 5. We are armed with the knowledge we need to calculate Q1. Q1 is the number in between 4 and 5. So we're going to add them together and divide by 2. Get out my trusty calculator here, 81.6 plus 82. Divide that whole thing by 2. Did I say 82.0? Maybe I didn't. 81.6 plus 82.0. Divide that whole thing by 2, and I get 81.8. All right, so we have Q1. Hooray! We have half of what we need. Now we need to find Q3. We need to find these 12th and 13th values. So let's start at the top and go down now. So let's see. I'm looking for hundreds, 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 hundreds. Oh, I didn't mark these off, but I used them. 100, 100, 100, 100, 100. There's one. We have 104.9, and that's the only one. Let's look for 90s. No. There's one. 96.4, 90.8, 94, and 91. Looks like we have 4 of them. So maybe I'll mark these. There we go. There's the 4. The lowest one of these is, or actually we're going top to bottom, right? So we want the largest one. The largest one is 96.4. Okay. Next one down is 94, it looks like. 90, 94, 91, 94.0. Then 91.0. Then 90.8. And let's just check in and see where we are. This was number 16, this is 15, 14, 13, and 12. We have got the numbers we need. We've got 13 and 12, which will evaluate Q3. So let's get Q3 now. Q3 equals the number in between 12 and 13, so we're going to add those values together. 90.8 plus 91.0. Divide those by 2. So once again with my calculator, 90.8 plus 91, divide that by 2, I get 90.9. And now ultimately I'm looking for the interquartile range. So there's my last calculation. The IQR is Q3 minus Q1. So that will be 90.9 minus 81.8. Let's see what we get. 9.1. Now cross our fingers, this is actually a number in the multiple choice. Let's see, 9.1 is right there. This is C. Now it might not have seemed like we saved a lot of steps by leaving out, oops, I'm sorry, these were supposed to go in the 80s. That's a mistake. But anyway, we might not have saved a lot of trouble by not having to sort these other 80s, but saving any trouble at all is pretty good. Like, ordering 16 numbers is not my favorite process. So if we can save a few steps, that is all right with me. All right, let's look at the last one we skipped here. Number 10, a circle is inscribed in a square as shown. If graphed on the coordinate plane, the coordinates of the center of the circle would be 2, 5, and the coordinates of one other point on the circle would be -2, -2, or sorry, -2, +2. Find the area of the square. Oh, this looks interesting. There's kind of a lot going on here. So I'm just going to write on the diagram what they told me. The center of the circle is 2, 5. And the coordinates of one other point would be -2, +2. So -2 would be kind of over this way, and +2 would be a little bit below the 5. So something maybe kind of over here. said the point is on the circle, so maybe somewhere around there. And notice that if we draw a line between those 2 points, we get a radius. A radius is the distance between the center and the edge. So this is the radius of that circle. However, we can also determine that distance, can't we? Because we learned how to calculate the distance between 2 points in the coordinate plane. Now, I like to draw my own coordinate plane because it makes it just a little bit less complicated to look at. So I'm going to regraph these points. 2, 5. That's 1, 2 on the x, and 1, 2, 3, 4, 5 on the y. Put my point right there. And then -2, +2. So -2, and then up 2. There's my other point. And we want to find the distance between them. We remember we construct our right triangle. We draw that as the hypotenuse. And then we draw a vertical line and a horizontal line. We determine the length of each of these sides. So if you look on this bottom one, you can see we can even count 1, 2, 3, 4. The length of this bottom side is 4. And the length of the vertical side is up 1, 2, 3. 1, 2, 3. So this is a very common triangle, a Pythagorean triangle, or a right triangle that has legs 3 and 4. You might already know, just from having seen these many times, that this side is 5. This is known as a 3, 4, 5 triangle. But even if you don't remember that, we can use Pythagorean theorem to find it. Remember, a squared plus b squared equals c squared. 3 squared is 9. 4 squared is 16. 9 plus 16 is 25. We're going to root both sides to get rid of that square root. Root of 25 is 5. This equals 5. So we calculated 5 using the Pythagorean theorem, but you could also just remember that 3, 4, 5 triangles are very common. You might see them. You can assume that the other, if there's one missing, it fits that form. 5 is the hypotenuse, 3 and 4 are the legs. All right, so we found the radius now. We know that the radius is 5. I'm just going to erase these points for a second because I think that was the majority of the purpose of having those points, was finding that distance. Now let's look at the rest of the problem. Find the area of the square. Well, we might need to look at this a bit, kind of stare at it, see if we can decompose this square. But you might notice that if we draw this radius and we draw this radius, so essentially we've drawn a diameter, right? We drew a line all the way across through the center. Well, the radii of a circle all have to be the same. This is length 5, this is length 5. And we add those two together, we get the side of the square. So 5 plus 5 is 10. The length of the side of the square is 10. But this is also a square, so we know that all the sides are of equal length, so this side is also 10. This side is 10, and this side is 10. Okay, so we are almost there now. We just need to find the area of the square, which we know is length times width. 10 times 10 is 100. So our answer on this one is D.